Hello everyone. Today I would like to discuss about the total factor of productivity growth in SFA. There are some input and output in the agriculture. This is, for example, for input it consists of the machinery, seeds, chemical, and extra. And then this is the process in the on-farm, and this is the output. Maybe output can be in the form of the rice, uh, corn, and so on. And then what is the productivity? The productivity is the major output per unit of input. If the input is labor, we call it the labor productivity. If the input is capital, we call it the capital productivity. If the input is land, we call it the land productivity. However, if the input is combination of the sum input, for example, labor, capital, and land, we call it the total factor productivity. Okay. In the single input and single output case, the productivity change in simple is different in the rate of change in y and x. The productivity change when there are multiple input is measured by what is popularly known as the TFP change. The measurement of total factor productivity growth and its decomposition has been the subject of investigation in many empirical studies of industrial productivity. The various approaches used in the literature have been classified into parametric estimation and nonparametric estimation. In the context of SFA, the total factor productivity change over time is not observed directly, but inferred from the changes in output that cannot be explained by changes in input use. This is the TFP decomposition. The TFP change is consist by three. The first is technical change, the second is technical efficiency change, and the third is the scale effect. If the TFP change is greater than 1, it reflects the existence of progress. If the TFP change equal 1, it reflects no change. But if the TFP change less than 1, it reflects regress in the productivity. How to calculate the TFP change? In here, I try to explain step by step. The first, we should estimate the SFA model. The second, we calculate the technical change. The third, we calculate the efficiency change. The fourth, we calculate the scale effect. And the last, we can calculate the TFP change. First, we should be assume the protection function. We can be in the copy class, or we can be use the translog, and maybe the other model. In our case, I try use the copy class and use the Patisi and Coley 1995 model or PC95, and we use the start data syntax like this one. As a panel is learn output, learn input 1, learn input 2, and etc. And this we include the T to catch the technical change, and comma model PC 1995. And for technical change, the technical change reflect shift in the protection frontier over time. With calculus, this comes from the coefficient of MT. So we can get the value by type the generated technical change equal underscore P T. In the calculus, the TC will be constant, but if we use the translog, so the TC will be variation. second, efficiency change. This represents movement toward or away from the frontier. From Stochastic, we first to predict the technical efficiency by Stochastic syntax predict TE, T, and then we generate efficiency change TE minus TE in the before. And for scale effect, we use two terms. First is return to school or RTS. RTS is beta 1, beta 2, beta 3, beta in the input. And then RTS is in the Stochastic syntax. Generate RTS equal underscore p learn input 1 plus underscore p learn input 2 and so on. And the second term is input mix group or delta input. We can get in this data by type the generate delta learn input is equal learn input minus learn input either before or the last time, and then input group equal the delta input 1 plus delta input 2 and delta input 3 and so on. And the scale effect, the formula is scale effect equal the RTS minus 1 multiplied by input group. The data syntax generate scale effect equal RTS minus 1 multiplied by input group. In the RTS we can conclude like here, if the RTS is greater than 1, it means increasing return to scale. If the RTS is equal 1, it means the constant return to scale. And if the RTS less than 1, it means decreasing return to scale. And the last is the TFP change. The TFP change is generate TFP change equal to technical change plus efficiency change plus scale effect. Okay, this is our summary. This is the if we use the translate. So this is the formula. This is the programming function. This is the TFP change. The technical thing is different with the compute class. This is like this one. Scale effect also different formula, but for the technical thing is same, and then the TFP thing is same. This one the summaries. Okay, right now I would like to demonstrate how to calculate the TFP change in the data. Okay, first we open the data program and then we open our data. In here I will use the rise data. So I will try to explain the variable. This is the time. This is the first year, second year, third year, 4 year, 5 year, 6 years, 7 year, and 8 years. So our observation consists of 8 years. And this is the farmer 1, farmer 2, farmer 3, until farmer 43. And then we try to use this one. This is learn output. Mean the price production. And this one the learn labor. And this one the learn area size, and this is the learn fertilizer. I will use 3 input and 1 output. Okay, first I would like to test whether the efficiency is exists or not in our model. So first I would like to run the regression model. But before I will set the panel. Actually, set farmer and then the year. Enter. Okay. And then we run the regression model. Regress. Output, level, area, word, and time. And then move the then enter. And scalar likelihood OLS is equal estimation likelihood. Enter. Okay. Now I would like to run the SFA model. So SF panel, then output, then labor, then area, then port, time, year, and then model, PC, and TFP. Enter. And then we click the likelihood value, scalar, likelihood, MLA is equal estimation likelihood. Okay. Display -2 multiplied by likelihood OLS minus likelihood MLA. Okay, the result is 49.57. Now we will compare with the hot and palm table. We use in here we start translate normal. So the degree of freedom is 2. Then we use the 5% is 5.138, and the LR test is 49.5, is greater than the in the hot and palm table. Accordingly, we can conclude that the model is have the inefficient. So the inefficiency is exists in our model. So the SFA model is accepted. We calculate the after we get the SFA model, and then second we calculate the technical change. Okay, and I will generate this. The technical change is equal the underscore p here is year 2. Okay, this one, and enter. Check. We already get technical change. Like I mentioned before, the technical change will constant because in output class is constant. But if you use the translog, the technical change will have the variation. Okay. The second, we calculate the technical change. So we need to predict efficiency change EC is PC. Okay, and then we calculate the delta of EC TEC, technical efficiency change. EC minus LEC. Okay, we change it here. This one is, it means the technical efficiency. Wrong, yes, but this is the technical efficiency, and here is technical efficiency change. Okay, and now I would like to calculate the scale effect. First, we calculate the return to scale. We generate the RTS. Generate RTS equal the underscore P ln labor, underscore P ln area, and then underscore P fertilizer. Enter. Okay. And right now I would like to, this one is already done, and right now I would like to here input growth. Okay, generate T labor minus L labor, and then generate the area is equal to area minus L area, and then generate the fertilizer. Fertilizer minus L fertilizer, and then input growth generate input growth if TL plus TA plus TF. Oh sorry, this is generate, actually should be wrong type, change. It's okay. Right now we can calculate the TFP change. The TFP change, generate TFP change equal the TC plus TC, technical efficiency change, plus RTS minus 1 multiplied by input growth. Okay, we check here. We already get the technical change, the technical efficiency change, and then the RTS, and then the input growth, and right now we get the TFP change. Okay, I would like to see our summaries. Should be same in the name we generate. This is TFP is capital, so we should be same TFP change. We get here for technical change is constant. The maximum and minimum is same. The mean is 1.4%. So the average, the technical change is positive 1.4%. 1.4%, and then for technical efficiency change is positive 0.7%, and then for RTS it is 96.5%, is less than 1. So the average is our RTS is decreasing to scale, and then for input curl is negative, so the input it will be decreased for the average, and for TFP change in the average is positive 2.3% for TFP change. So we can conclude that in the average our TFP change or the productivity is positive 2.3%. And I want to see the one by one farmer, which farmer have the TFP change positive and which one the farmer have the TFP change negative. So the farmer code like this one, enter. We get all farmer. We start for farmer 1. The technical change positive, technical efficiency change is positive, and the RTS is the decrease the scale. For the input curl is negative, but for the TFP change is positive. For farmer 2, we can see here, farmer 3 is like here, farmer 4 like here. Okay, thank you for your watching, and I hope our tutorial is benefit for you, and bye bye.